Hi everyone, and welcome to the Mat 211 review of probability density functions. My name is Julia, and I work for the tutoring centers at ASU. So we have this function, f of x equals k times x squared, on the range 0 to 1. We want to determine the value of k such that f is a probability function. Now, the first thing to note here is that we never want f of x to be a negative value. This is because it's supposed to be representing a probability function, a probability density function, and probability functions are between the range 0 and 1. So we can't have any values outside, this particular range for f of x. So if we look at the terms in f of x, we have, f of x is equal to k times this x squared. So x squared can never be negative, even if, x is, -1, for instance. Well, when we square it, it's going to be a positive value. So any value of x is always going to be positive once we square it. So this part of the term, that's not going to be a problem. However, this k, depending on what this value for k is, this could potentially make our f of x function negative. So what this means is that we need to ignore the range where k is less than 0. So when k is less than 0, it's going to be a negative value. And a negative value in here times whatever our positive value of x squared is going to produce a negative value for our f of x. So we don't want the values where k is less than 0. So we want to restrict our attention to values of k that are greater than or equal to 0. So now we want to determine what k actually is. We know it's got to be in this, range k is greater than or equal to 0, but we don't know what it is yet. The way to do this is to solve the integration negative infinity to positive infinity of the probability density function f of x dx equals 1. So what this means is that to be a probability density function, this integral here has to evaluate to 1. So let's go ahead and substitute in our particular values. So we'll just put the integral bar here now, and we're going to substitute in our definition of our function f of x. So k x squared dx. Now note that f of x is restricted to the range 0 to 1. So that means that any value, if f of x is a probability density function, then any values outside of 0 and 1 for x are going to mean that f of x is equal to 0. So we don't need to consider those values since they're not going to add anything to our integral. So we can restrict our range rather than evaluating from, negative infinity to positive infinity here. We can restrict our range from 0 to 1. So now we want to integrate this. This is going to be equal to k x times x to the third over 3 evaluated at from 0 to 1. So if we evaluate this from 0 to 1, we're going to get k times x to the third, or 1 to the third here, which is 1. So k times 1 over 3. And, whoops, don't want to forget our second part of our evaluation here. Then we're going to subtract from that the value of this function evaluated at 0 for x, which is going to be k 0 to the third over 3. Well, this term just equals k over 3 minus 0, since we have a 0 in here, so we have a 0 in our numerator. So we have just k over 3. Now this has to equal 1, remember. So let's pull this out to the side over here and we'll solve for what k needs to be in order for this all to evaluate to 1. So if we know that k over 3 has to equal 1, then k has to equal 3. So that's it. That's all it takes. So we know that in order to make our function here, f of x equals k times x squared, a probability density function, on the range 0 to 1, we need to have k be equal to 3. Now, before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can visit the Tutoring Center's website, tutoring.asu.edu, to find all of our different resources. Also, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find off of our main website here, or by going directly to the tool at this full link on the screen. So thanks so much and have a great rest of your day.